In physics, time is a dimension in which events take place in a seemingly uninterrupted sequence from the past to the present to the future. But this is wrong. Brian Cox has just announced a groundbreaking theory of time that will blow your mind. We may be living in a continuum where the same thing is always happening, and we are just imagining time. Now, let's see why that is. Brian Cox is known to every child in the UK. For decades, Cox has been explaining complicated scientific and physical facts in a simple and understandable way. In addition to gravity, Brian Cox is also interested in the nature of time. Honestly, have you thought about time today? You probably have. You may have looked sleepily at your alarm clock this morning and thought to yourself, it can't be that the night is already over. Or maybe you were late for the subway or arranged a date at a certain time. However, none of this is time, at least not the way physics or possibly our universe sees it. Time is a fascinating fact and a quantity that puzzles researchers in physics. The arrow of time is a concept that describes the one-sided direction or asymmetry of time. We always experience time as seemingly flowing in a certain direction, from the past to the present to the future, from youth to old age, and from yesterday to today and tomorrow. But this idea of time only exists in our heads. It is not real. It is much more likely that time passes completely differently in different places in the universe or that it does not exist at all. Einstein said, "Time is what you read on the clock." In classical Newtonian physics, time was regarded as a constant, unchanging quantity that was independent of space and motion. However, Einstein showed that time can run differently for different observers depending on their relative speed and gravity. This means that time is relative and has to do with subjective perception. For you, time can run very differently than it does for me, depending on the activity and the state of mind you are in. Different creatures probably also have completely different perceptions of time. An elephant probably perceives the sequence of events and time spans very differently from an ant or a mouse. Einstein also came up with this beautiful quote, "Put your hand on a hot stovetop for a minute, and a minute seems like an hour. Sit next to a pretty girl for an hour, and it seems like a minute." That's relativity. But what is time if it is not a fixed quantity? We perceive time as being dependent on matter. For us, time is the sequence of events and a subjective feeling that we have. You get up, brush your teeth, make yourself a coffee, and time passes. But if we look closely, there is no element called time, neither in your bedroom nor in your kitchen. We have clocks that tell us a specific time, but they are an invention of us humans. Did you know that no day has exactly 24 hours and no year is 365 days long? We invented these time units to organize our everyday lives. But this time is not real in the sense of a physical dimension. If we take our watches, which function as timepieces, an exciting thing happens. What we call time passes between two jumps of the hand. The hand indicates an event. If it jumps further, the next event happens. Now, thanks to our physics, we know that even clocks start to behave strangely when they are exposed to certain conditions. One of these phenomena is time dilation due to gravity. Mass causes gravity, and Einstein's general theory of relativity states that the presence of mass bends space and also influences time or the sequence of events. This leads to a phenomenon known as gravitational time dilation. In a stronger gravitational field, time passes more slowly compared to a weaker gravitational field. This has been experimentally confirmed by clocks at different heights. For example, the clock runs faster on a mountain and slower, closer to the center of the Earth. The phenomenon of time dilation in the vicinity of mass is also found in black holes. In the vicinity of extremely massive giants, time would almost stand still from the perspective of a distant observer. The extremely strong gravitational force therefore stretches time so much that the clock stands still. Another practical example of the effects of gravitational time dilation is the Global Positioning System, also known as GPS. GPS satellites are in a higher orbit where the gravitational force of the Earth is weaker. As a result, time passes a little faster at satellite altitude than on the Earth's surface. To provide accurate positioning data, engineers have to program these shifts into their GPS systems. Brian Cox says gravity is wrong. It sounds strange, but Brian Cox is absolutely right. Nobody knows what gravity really is, and we don't know if it really exists. It's just like time. Isaac Newton could observe gravity but could not describe what it is, where it comes from, or what this force does. We only know the effect of attraction. If we drop something, it falls to Earth. We can only stand on our planet because it somehow attracts or holds us in space. This force is absent, and our bodies experience weightlessness. Only when space travelers approach another planet would they come into contact with an attraction again. On some planets, this effect is similar to ours, and on other celestial bodies, it is completely different. On Mercury, the gravitational pull is only 38% of that on Earth. Your weight, there would only be about a third of what you weigh on Earth. A 100 kilograms person would weigh about 38 kilograms there. The situation on Mars is very similar to that on Mercury. Future Mars settlers will weigh only a third as much there and will probably develop a completely different sense of time. Titan, Saturn's largest moon, could also one day become a destination for humans. On Titan, humans would feel almost weightless, as their weight would be only 14% of Earth's weight. Even on the way to these distant planets or moons, space travelers would again encounter time dilation. As soon as the spaceship moves away from Earth, time passes differently. This becomes even more extreme if spaceships were to travel close to the speed of light. For the space travelers on board, time would seem to pass normally. They would eat, sleep, and carry out experiments just as they would on Earth. But to an observer on Earth, it would appear as if time on board the spaceship was passing more slowly. At the destination, time would pass differently due to the completely different gravity. And when the space travelers returned to Earth, much more time would have passed there than in space. We do not yet know how these effects would affect people in space. But let's go back to Brian Cox's fascinating statement that gravity may not exist at all or not in the way we imagine it. Gravity is now generally regarded as a fundamental force that causes objects with mass to attract each other. Einstein described it as the curvature of spacetime by mass and energy. A star has a certain weight and thus bends or curves spacetime. Other nearby masses are drawn into this funnel. According to these ideas, you also bend spacetime a little bit with your weight and thus plop into the Earth's funnel, so to speak, so that we stick to the ground with our feet and don't fly through the air. Brian Cox is quite right in his view that gravity is not necessarily a force, but rather a geometric aspect of spacetime. If we go into the vastness of the universe, a fascinating aspect emerges. The rotational speeds of galaxies and the movements of galaxy clusters do not conform to the forces of gravity. For this reason, researchers came up with the idea of dark matter, the existence of which has not yet been proven. What if I told you that time does not exist? Many spiritual traditions, especially Eastern religions, claim that time is an illusion. In truth, there is only the present moment. The impression of time is created by our subjective judgment of the world around us and our actions within this world. If we were to leave this out, our perception of time would cease abruptly. Of course, there would still be effects, such as the ripening of apples on a tree or the aging of your body. But if you believe these views, they are also just effects, optical illusions that enable us to experience this world. Buddhist monks are able to slow down their breathing and heartbeat to such an extreme that, according to the rules of Western medicine, they should actually die. However, these people are able to outweigh the subjective impression of time or even suspend it completely for a few moments. There is also evidence that specially trained monks override the laws of gravity by chanting. This is exactly how the Egyptians are said to have transported the heavy stone blocks with which they built the pyramids. Chanting and the will of the monks correspond to a vibration and a force of consciousness. Apparently, these forces seem to be far above what we would call reality or fixed physical quantities. The world of these quantities and units of measurement very probably only reflects one dimension of possibilities. Presumably, as a collective and as humanity, we share an awareness of time that we infect each other with through our thoughts and actions. Many people are familiar with the feeling that time passes more quickly with age. However, researchers have now discovered that this is not true. It is simply the case that our brains are no longer quite as open and perceptive as children's brains as we get older. Over time, fixed pathways form in the brain, and researchers have found that the brain can simply block out different time units of activities. This gives the impression that time is lost. Of course, our bodies age, but we could probably control and extend these processes by consciously dealing with time. An age of 80 or 100 years would seem like 200 or 1000 years. Subscribe now and never miss a new video. Hit